This video is on adding and subtracting radical expressions. In order to add or subtract radical expressions, both the indexes and the radicands must be the same. Here's a couple of examples of radical expressions that cannot be combined. So here we have square root of 2 plus the cube root of 2. They have the same radicand, but their indexes are different. A square root has an index of 2, cube root has an index of 3, so those cannot be combined. And square root of 2 plus square root of 3. They're both square roots. They have the same index, but they have different radicands. So neither of those expressions, we would say that they're in simplest form. They cannot be combined any further. However, when the indexes and the radicands are the same, you can combine what looks like the coefficient in front of each radical expression. So for example, if we have a times the nth root of x plus b times the nth root of x, add a and b, and that would be that times the nth root of x. And the same is true for subtraction as well. So for example, if I have 3 times the square root of 5 plus 6 times the square root of 5, that's equal to 9 square root of 5. And this one looks a little complicated, but it does work. 8 times the fourth root of 3x minus 10 times the fourth root of 3x is equal to negative 2 times the fourth root of 3x. Notice that both expressions have the same index, they're fourth roots, and they have the same radicand, 3x. So you just combine the numbers that are being multiplied out front, what looks like a coefficient. If a single radical expression can be simplified, you want to do that first before you add or subtract. So let's take a look at several examples here. Actually, I think I just have 2 examples. So we need to simplify each expression. Number 1 says 14a times the square root of 7bc plus 5a times the square root of 7bc. We need to figure out what that equals. So notice that the indexes are the same, they're both square roots, and my radicands are the same, 7bc. And I can combine my 2 expressions out front. So 14a plus 15a is 19a times the square root of 7bc. And that's what that would be simplified. Next one's a little more complicated. We have the cube root of 250 plus the cube root of 54 minus the cube root of 16. Notice they all have the same index. They're all cube roots, but my radicands are different. So before we just kind of throw up our hands and say we can't do this, I'm wondering if I can simplify each one of those expressions. So again, let's take a look at some of the factors of 250 and see if any of those are cube roots. Well, 250 is 2 times 125, and 125 is equal to 5 to the third power. Remember, I'm looking for factors that are raised to the third power since I've got a cube root here. So that means that I can write the cube root of 250 as 5 times the cube root of 2. Let's take a look at 54. 54 is 2 times 27, and 27 is 3 cubed. So I can write the cube root of 54 as 3, remember the cube root of 3 is going to be 3 out front, times the cube root of 2. 16 is 2 times 8, and 8 is 2 cubed. So I can write negative cube root of 16 as negative 2 times the cube root of 2. Now each of my expressions has the same index, 3, and the same radicand, 2, so I can just combine the numbers out front. So 5 plus 3 minus 2 is 6, so this is equal to 6 times the cube root of 2. So in this video we took a look at how to add and subtract radical expressions, remembering that the indexes of all the terms need to be the same and the radicands of all the terms need to be the same. And if necessary, we want to simplify any individual term before combining them.